Hey there, Mr. Weaver here, and this is Topic 9, Lesson 4, Solving Quadratic Equations Using the Quadratic Formula. After this lesson, you need to be able to calculate the discriminant. You need to be able to use the discriminant to determine the number of solutions a quadratic equation will have, and you need to be able to solve for the variable in quadratic equations using the quadratic formula. You'll know you're successful after this lesson if you can calculate the discriminant, predict if there are no one or two solutions to a quadratic formula using the discriminant, and if you can solve for the variable using the quadratic formula. The quadratic formula is a sort of complicated looking formula that can be used to find the solutions for any quadratic equation. The letters in it, A, B, and C, have to do with the locations of where the numbers are in standard form. Like A is the first number, B is the second number, C is the third number. If an equation is not written in standard form, you must rewrite it in standard form first in order to use this. The quadratic formula is the fourth method we are seeing of how we can solve for our quadratic equations. So first, you need to write the equation in standard form if it's not already. Then identify A, B, and C. Those are your coefficients. Third, substitute the values of A, B, and C into our formula. 4, simplify it as much as you possibly can. And then 5, split the expression into two equations, that plus or minus, and solve for x. In some cases, though, we'll see where when we can't simplify any farther, we'll just leave it as the plus or minus. Another part of the quadratic formula is what is called the discriminant. The discriminant is essentially what is inside the square root of the quadratic formula. It's b squared minus 4ac. And this value can help you predict how many solutions there are. So, based on its value, it tells you how many solutions there will be. After you plug in a, b, and c and simplify it out, if your answer is positive, there will be two solutions to your quadratic. If the answer is 0, there will be one solution. And if the answer is negative, there will be no real solutions. So we will see going forward that discriminant will help us tell how many solutions we get, and we will use it as part of our quadratic formula. So let's get into how the quadratic formula works here. So we have 2x squared plus 3x minus 77 equals 0. This is written in standard form. It's already something x squared, and then something x, and then a constant. And if it's not already set equal to 0, for this, we're going to set that equal to 0, but here it is. So a is the coefficient in front of x squared, b is the coefficient in front of x, and c is your constant. Yes, I labeled underneath them, but I'm also going to write out that a is equal to positive 2, b equals positive 3, and c equals negative 77. Now, we're going to take our quadratic formula. The formula is something you are going to need to memorize. And there are some good, catchy songs on YouTube that can help you memorize it. So we have negative b plus or minus the square root of b squared minus 4ac all over 2a. Once we know our values for a, b, and c, we can plug in the numbers. So here I just put parentheses where all of our letters were, and now we're going to fill them in. So the first is b. B was 3, so I'm going to substitute a 3 in its place. The next one is also b, plugging in 3 again. The next parenthesis is an a. A was 2. C is negative 77. And then in the denominator, we have another parenthesis that is for A. A is 2. So we filled in our A, B, and C's where they went in the formula. From here, we're just going to simplify it out as much as we can. I'm going to start inside the square root. So 3 to the second power is 9, and then negative 4 times 2 times negative 77 is positive 616. And while we're thinking about it, remember, the inside of that square root is called the discriminant. Here, 9 plus 616, that's going to end up being a positive number. So that's going to tell us we have 2 solutions, and we should keep going. If it was negative and there were no solutions, then we could just stop because there's no real solutions. Since it's positive, we'll keep going. So I'm going to add those together. 9 plus 616 is 625. Still working on simplifying it out. Again, that discriminant is positive, so there's 2 solutions. Now I'm going to take the square root of 625, which is 25. The plus or minus symbol is already there, so in this one you don't necessarily need to remember to do that. Next, I'm going to split into the plus and the minus. So I'm going to do negative 3 plus 25, and I'm going to do negative 3 minus 25. That 4 isn't part of the plus or minus. We'll add that back in a minute. So negative 3 plus 25 is 22, and that's over 4, which comes out to be 5.5, or 11 over 2. For negative 3 minus 25, we get negative 28 over 4, which means x equals negative 7. So our solutions to this using our quadratic formula are 5.5 and negative 7. Reminder, we could check to make sure we're correct in Desmos. If we type in our original function, it would cross the x-axis at 5.5 and at negative 7. Now it's your turn. Pause the video. Use the quadratic formula to figure out the solutions of this quadratic. Let's check. You should have got x equals 4 and x equals negative 3. Let's look how to get that. Start with our quadratic formula. Here, A is positive 2, B is negative 2, and C is negative 24. If we plug in our numbers, notice out front it's negative 2. So by using those parentheses, we can help make sure we keep our positives and negatives straight. So out front, that negative 2 becomes positive 2, and then simplifying the square root, we end up with 4 plus 192. 4 plus 192 is 196. The discriminant inside there is positive, so we're going to have 2 solutions. We'll keep going. Square root of 196 is 14. Split it, so 2 plus 14 is 16. 2 minus 14 is negative 12. And then both of those are over 4. So 16 divided by 4 is 4, and negative 12 divided by 4 is negative 3. Let's look at another example. This time, our equation is not in standard form. So first, we're going to need to rearrange it a little bit so we get it into standard form. It's pretty close. All we really need to do is subtract that 27 from the right, and then do it from the left. So we end up with 4x squared minus 3x minus 27 equals 0. Now we're in standard form. Identifying our A, B, and C. A is positive 4, B is negative 3, C is negative 27. Let's plug them into our formula. So B, negative 3, A is 4, C is negative 27, and then A on the bottom is 4. Just like last time, we have a negative out front. So that's going to turn it into positive 3. And then inside our square root, we have 9 plus 432. And then on the bottom, we have 2 times 4, which is 8. So let's simplify our square root. We get 441. Take the square root of that. We get 21. So I'm going to do 3 plus and minus 21, and then divide it by 8. So 3 plus 21 is 24 over 8, which means x equals 3. 3 minus 21 is negative 18, divided by 8 comes out to be negative 2.25, or negative 9/4. Again, all I'm doing is identifying A, B, and C, plugging in the numbers, and simplifying it as much as I can. So now it's your turn. Pause the video. Determine the solutions of this quadratic using the quadratic formula. Let's check. You should have got x is equal to 12 and x is equal to negative 9. Let's look at how to get that. So first, you should have subtracted 108 from both sides. That way it's in standard form, meaning a is equal to 1, b is negative 3, and c is equal to negative 108. Don't forget, there's a hidden 1 in front of x or x squared if it doesn't look like there's a number there. Plugging those numbers in. Simplifying, again out front, there's that negative, so positive 3. Inside we have 9 plus 432. This one just happens to be the same inside as our example. The bottom though, divided by 2. So 3 plus or minus the square root of 441 over 2. 3 plus or minus 21 over 2. So if you add them, you get 24. Then divide by 2, you get your 12. If you subtract 3 minus 21, you get negative 18. And then divide that by 2, you get negative 9. Let's look at our third example. So here, again, we have our function that is not in standard form. So if we want to use the quadratic formula, the first thing we need to do is rewrite it in standard form. So I'm going to subtract 2x from both sides, and then I'm just going to place it where it needs to go. So that minus 2x would be in the middle. X squared minus 2x minus 168 equals 0. Now I have standard form. Let's identify A, B, and C. So A is equal to positive 1, B negative 2, and C negative 168. Using our quadratic formula, we can plug in our numbers. So negative 2 plus or minus the square root of negative 2 to the second power minus 4 times 1 times negative 168 all over 2 times 1. Let's simplify that out. Combine our square root. Take the square root. Now we can separate. So 2 plus 26 is 28. And then 2 minus 26 is negative 24. Both of them divided by 2. You end up with x equals 14 and x equals negative 12. So hopefully you are starting to notice it's the same process over and over. Just make sure you are identifying A, B, and C correctly, plugging them into the right spots, and simplifying it correctly. So now it's your turn again. Pause the video. What are the solutions to this quadratic? Let's check. Here you should have got 4 plus or minus the square root of 52 over 2. Now I just left it as a square root here. If you changed that square root into a decimal of 7 point whatever it is, then your answers might be slightly different, yet still correct. So let's look how to get that and how I kept it as the square root of 52. So first, subtract 8x from both sides. So we get our equation in standard form. A is 1, B is -8, C is +3. Plugging those in to their correct spots and simplifying out, we get 8 out front plus or minus the square root of 64 minus 12 over 2. So 8 plus or minus the square root of 52 over 2. And then that 4 comes because if I divide 8 by 2, I can get 4. But I'm showing that I don't know, or it doesn't come out evenly to do the square root of 52 divided by 2. If you used decimals, then you also might have other versions of a correct answer, but this is our exact answer without rounding at all. Let's look at one last example. So here we have x squared minus 6x plus 23 equals 8. First, I see there's a constant on the right side. I'm going to subtract 8 from both sides, so it's on the left, and now I'm in standard form. X squared minus 6x plus 15 equals 0. A is now +1, B -6, C +15. Plugging in our values to our formula, we end up with -6 plus or minus the square root of 36 minus 60 over 2. Here's another place where looking at the discriminant can be very helpful. So in all the other examples, our discriminant always was positive. So we always got 2 answers. Here though, we have 36 minus 60. So that inside is your discriminant. If you combine and simplify that, you end up with -24. You're trying to take the square root of -24, which hopefully by now you're realizing that you can't take the square root of a negative number and get a real answer. So if that number inside the square root comes out to be negative, there are no real solutions. So if the discriminant is negative, that's why there are no solutions, because you're trying to take the square root of a negative. So since there are no solutions, we can stop and don't need to continue on anymore. Now it's your turn one last time. Pause the video. Use the quadratic formula to find the solutions of this equation. Let's check. You should have got x is equal to 8 and x is equal to 0.2 or 1/5, depending on if you left it as a fraction or changed it to a decimal. Here's how to get that. First, add 4 to both sides, so it's gone off the right. Now we have a is equal to 5, b is -41, c is 8. Plugging in those numbers, simplifying it out, we end up with 41 plus or minus the square root of 1,521, all over 10. Lucky for us, the square root of 1521 is 39. So we're actually ending up with 41 plus or minus 39 divided by 10. So adding them, you would get 80. 80 divided by 10 is 8. Subtracting, you would get 2. 2 divided by 10 either simplifies to 1/5, or dividing it, you get 0.2. In this lesson, we learned about the quadratic formula, which is another method of solving quadratic equations that always works. The formula may look complicated, but in reality, you just need to identify a, b, and c in the equation, and then substitute those values into the formula. Then simplify it down as much as possible. This method will become especially useful when a, b, and c are not whole numbers, so they're either decimals or fractions, or if all of the numbers, a, b, and c, are not divisible by a, which, if you remember from lesson 3, is what you would need to do to complete the square. Within that quadratic formula, there's also the discriminant, which is located inside the square root part. The discriminant value there, that b squared minus 4ac, It's useful for determining how many solutions the quadratic equation will have. If the discriminant is positive, there will be 2 solutions. If it's exactly 0, which we didn't see any examples of, but if it's exactly 0, there will only be 1 solution. And then if the discriminant is negative, then the equation has no solutions, since you're trying to take the square root of a negative number, and you don't get a real number doing that. So after this lesson, do you now know how to calculate the discriminant? So b squared minus 4ac, what was under that square root? Do you know how to predict if there are no 1 or 2 solutions to a quadratic equation by using that discriminant? And can you solve for the variable using the quadratic formula? If you're not sure about the first 2, look within some of the examples to see how that number under the square root can help you determine. If you're not sure about the last one with solving, then rewatch any of the examples to see where the numbers go and how simplifying can help. And that's the end of lesson 4 on solving quadratic equations using the quadratic formula.